Hi everyone. Welcome to my channel. Today we're looking at binary to gray code conversion. In this tutorial I'll show you how to convert binary to gray code, write the Verilog code for it, and create a test bench to simulate it. Let's get started by understanding the concept of binary to gray code conversion. The primary reason for converting binary to gray code is to reduce the risk of errors during transitions in digital systems. It's particularly useful in applications involving sensors, communication systems, and digital circuits, where accurate data and error-free transitions are critical. In binary code, changing from one value to another, for example 0111 to 1000, may involve multiple bits changing simultaneously. In this example, 3 bits are changing at once, which increases the chance of errors during the transition. Gray code ensures that only one bit changes at a time between successive values. This reduces the chance of multiple bit errors, making it ideal for systems that rely on precision, such as encoders and sensors. Let us see the change when we are changing from 7 to 8. The first bit changes from 1 to 0. As you can see, the second and third bit too change from 1 to 0. The most significant bit also changes from 0 to 1. In order to move from 7 to 8 we have to change all the 4 bits. In gray code the first 3 bits are the same. Only the most significant bit changes from 0 to 1. In gray code 2 successive values differ by only 1 bit. This is often used in applications like digital communication to reduce errors. Let's convert the binary number 1100 to gray code. The most significant bit of the gray code is always the same as the most significant bit of the binary number. In order to get the remaining bits we XOR the binary bits according to the following. Let us construct the truth table for an XOR gate. To get G2 we XOR B3 with B2. One XOR 1 gives us 0. For G1 we XOR B2 with B1. One XOR 0 gives us 1. For G0 we XOR B1 with B0. Zero XOR 0 gives us 0. Now try to do the second example using these assignments. Let us open Visual Studio Code and create a folder. Create a file to write the Verilog module to convert a 4-bit binary input into its corresponding gray code. Now let us write the code. We have a 4-bit binary input and a 4-bit gray code output. The MSB of the gray code is directly taken from the binary number. For the remaining bits, each gray bit is the XOR of the current binary bit in the bit 1 position to the left. Let's create the file for the testbench code. We apply different binary values to test the conversion. We use the display function to display the binary input and corresponding gray code output at the terminal. Go to File and save your code. Open the terminal to run the simulation. I have included the commands for compiling and running the code through the terminal on the description below. This is our simulation output. In this project, you learned how to convert a binary number to gray code in Verilog. This exercise helps improve your understanding of logic operations like XOR and how to implement them in hardware description languages like Verilog. Thank you for watching. Don't forget to like, subscribe and share.